Okay, welcome again. Welcome to this episode where we're going to talk about longitudinal stability analysis. In the previous episode, we did a normal static calculation where we just wanted to calculate force and moment to get an idea about how many lift these foils generate and what the moment on this system is. Then we have let the Newton-Raphson algorithm find a approximate equilibrium position where we had a quite small z forces in the result and even smaller moment along the y-axis. And this is this approximate equilibrium state. It's also visualized here, which is the result. Once we have this equilibrium position, the only thing which rests us is to perform a longitudinal stability analysis, which is what we're going to do right now. Again, this can take a couple of minutes, so we'll skip right to the results. Okay, in the meantime, the results are here. Once you complete this calculation, you get the following plots. So this is a plot of your eigenvalues. This is a plot of your eigenvectors. So I'll just show them all for you here. So your eigenvalues, normally you have 5, only 4 of them are displayed here. That's because one is quite small and isn't plotted here. But what we can see is that we have a complex conjugated pair, which corresponds to this complex eigenvector. And then we got 3 real eigenvalues. We can make some conclusions. For example, here we have a nearly neutral. This is lambda 1. Lambda 1 is figure 2. Lambda 2 is figure 3 it is. Lambda 3 and lambda 4 is figure 4. And then lambda 5, which is not here, is this eigenvalue. What we see here is that we have a coupling between the elevation and forward speed, neutral coupling, which is lambda 1, which is something expect. Then here we have a wobbling motion, a coupling motion between the heave motion and also your pitch velocity. So it's some kind of wobbling motion, which is oscillatory in nature. Another exponentially decreasing eigenvalue we have here, and is a coupling between the heave motion, the pitch velocity, and so on. So we can make some interesting conclusions about this, but the first thing which we can conclude is that all eigenvalues are negative because they're all on the left side of the screen, meaning that this eigenvalue, which we see right here, these eigenvalues all correspond to a dynamically stable system, which is interesting. The more these eigenvalues move to the left, the more stable it gets, because then these motions will be dampened out more harshly, but this also maybe can lead to some unwanted effects because the ship would react too hard to certain effects because everything would be dampened out quite quickly. For a more detailed analysis, I suggest you get your own designs in there and see how certain design changes might affect your design. For example, one of the things which I've already tried is if you put this elevator, so your rudder, which actually makes sure that your boat is stable. If you move it a lot more forward, we'll see that this eigenvalue and these two will move to the positive real value, meaning that it becomes dynamically unstable, which is again something we would expect, which we can now really see in the results of this dynamic stability analysis. So we can also see how far forwards we can move this elevator to still have a stable system. So what's the shortest boat we can have in this design? We can just click this away. Another important thing, and that is quite important if you really want to work with it, is you have your eigenvalues and your stability matrix here. So you can just copy paste it from here, put it in Excel and to compare different designs, and you can store it on your own computer there. So I think I mentioned the most important parts of the Typhoon here, of the graphic user interface. As I mentioned, there is also a texturing interface if you use MATLAB. This is more complex, the learning curve is more steep, but once you get an idea of how this works, it should show itself how it works. So best of luck with your designs, and if there's any questions, hit us up via the GitHub link. There is a forum there where you can report some issues, you can report bugs, and so on. So if there is any issue or you have any question, don't hesitate. Contact us. Our contact details are on typhoon.ugent or maritime.ugent.be. And there you can find anything about all the other research we're doing. But you can also find our contact details, and we'll get in touch with you as soon as possible. So thank you very much, and happy foiling.